Hello, I'm Hans Holberg from BTC Embedded Systems, and today I'm here with Dr. Tom Bienmüller to dive into complexity of testing autonomous systems. Hi, Tom.
Hi, Hans. Testing autonomous systems can be quite a challenge, especially with the problem of test explosion.
Indeed, it's a real issue. Test explosion occurs when we attempt to test every possible scenario, which is almost unfeasible, as we know. So, Tom, what's the solution to solve this problem?
Well, one approach is to adopt a more strategic testing methodology. Instead of attempting to test exhaustively, we need to concentrate on the scenarios that are both highly probable and critical.
How do we identify these critical scenarios?
To narrow down the scenarios, we begin by carefully describing the ODD of the autonomous system. This involves not only understanding where and when the system operates, but also assigning probability distributions to various elements within the ODD.
So, essentially, we are not just looking at the static and dynamic factors, but also measuring how often they come into play.
Exactly. Once we've characterized the ODD, we proceed to create abstract definitions of potential driving scenarios within the domain, while also calculating the probability of occurrence. This allows us to focus our testing efforts more effectively.
But what about scenarios that may have a low probability but still pose a high risk?
That's an important consideration, Hans. To account for such scenarios, we need to factor in criticality elements, such as high speed situations, poor visibility, or slippery road conditions. Even if a scenario is unlikely, its potential consequences may still make it crucial to test.
Once we have pinpointed these critical scenarios, how do we streamline the testing process?
That's where weakness detection comes into play. It's an optimization algorithm designed to automatically explore various parameters in search of specific weaknesses within that system.
Could we elaborate a little bit more on how weakness detection works?
Sure. Weakness detection employs a mathematical function to define what represents a weakness. It then systematically investigates the scenarios we've identified to determine if any of them trigger that predefined weakness.
So finding a weakness signifies a potential problem within the system?
Exactly, Hans. If the algorithm detects a weakness, it's an indication that further investigation and refinement is needed. However, if it doesn't uncover any weaknesses, it suggests that the system is performing safely.
To summarize, our approach involves intelligent testing, focusing on likely and critical scenarios and utilizing weakness detection to uncover hidden issues.
Precisely, Hans.
Thank you for watching. If you enjoy this video, please give it a like and don't hesitate to contact us if you are interested to learn what BTC is doing in this area.